last section of chapter 8. So now we're getting into just the last couple data points that we got to identify, things like standard deviation and variance. So these are also deal with how spread out the data is. So if you look at these two examples right here, so we have one list of data for Jefferson Bank. So these are like wait times. So this how long this person waited. These are wait times at a different bank, right? And so you can see kind of some of the difference in the numbers, but there's 10 data points for each one. And so if we were to find the mean, the median, the mode, and some of those basic things that we've found before, you'll notice the answers are all the same, right? So if you notice those answers, we had different numbers up there, but I got the same mean, median, and mode for both banks. So anyone looking on with this would like more information about the difference between the two. And so the key on this is now to throw in something extra like standard deviation, which just tells you how spread out the wait times are or how much they vary by. If you were to look at the range of those same banks, so the range on the first one was 1.2. So again, that was just the biggest value minus the smallest value. But the range on the other bank was 5.8. So these are way more spread out than the first one was. And so now somebody interpreting this information can now take this into account. And so it just gives more information to somebody interpreting results of data. So a couple things on here. There is a formula for doing standard deviation. This is standard deviation and this is variance. Notice with standard deviation that it's got the square root, and the variance has the exact same formula without the square root. So one key to this section is for you to understand that the standard deviation is simply the square root of the variance. The other way to say that would be to say that the variance is the standard deviation squared. So you could say it either way, but that's the difference between the two. When we do these, we always deal with the population and not the sample. So I'll speak more to that here in just a second, but this is the symbol for population standard deviation, and this is the symbol for population variance. So notice it's just the same thing. The variance is the same thing as saying the standard deviation squared. And it just gets rid of the radical. That's all it does. So looking down at a few of these things, you could do the formula. I know it looks complicated. It's really not. All this is saying is the sum of your data. And how do I find the data that I want to add together? I take each data point, I subtract the mean, I square that answer. If I have frequencies, I would multiply it times the frequency. I would find the sum of all that information, divide it by the number of terms, and then take the square root of all that, and that would give me my standard deviation. So it's just a tedious process. It's really not that complicated. Here's an example of how that would look. So if I just took just 3 data points and I said find the standard deviation, well, you got to start by finding this guy, the mean. And so we would add them up, divide by 3. We'd say, okay, the mean is 75. So here's how they use the formula. So I got 75 for the mean, and I would just start with my first data point. So I would do 68 minus 75 squared times my frequency. I only have one of those, so times 1. And now I move on to my next term. And now I put 73 in there. So 73 minus 75, which is 2 squared, times the frequency. I only have one of those, so times 1. And then the last one would be 84 times 75 squared times 1. And now I would add those 3 answers together. This means a sum. So I'm going to add those 3 answers together. I'm going to divide by 3 since I have 3 terms. And then I would square root that answer to get my standard deviation. And so that's how they came up with this number. If I wanted to find the variance, keep in mind that I would just get rid of the square root. And then 134 over 3 would be my variance. And so those are definitely doable by hand, but if you had a big list of data, that would be awful. So this is not the norm that you'll be doing this thing by hand. Our calculator can give you this same information. Just a quick side note, in your calculator, you're going to see two answers for standard deviation. One looks like this symbol here. The other one has an S for a sample. The difference in a sample between population is they use n-1 right here instead of n. So that's why you get two different answers for that. So again, notice the change in symbol. The X with the bar is for a sample. So that's a sample mean. Oops. That's a population mean right there. And so they're both means, but again, the difference is that's the number of terms. Then for a sample, they do one less than the number of terms to get their sample standard deviation. We always use this. So don't use the S of X or S of N formula in your calculator. Use the one that looks like this. This, by the way, is just the lowercase version of this. So they're both sigma. So this is a capital sigma, and this is a lowercase sigma. But we use the lowercase sigma in the calculator, not S of X. So anyway, so that's all that. So if you were going to try this on a calculator, and you can give this a shot, but this is what you're doing on that. But if you plug this into list 1, do your one variable stats, you're going to see this symbol for population. That's the one that we use, and so you would get this answer. Notice we're not using the S of X for sample, we're using population for this one. If you were to do the same thing with a frequency list, so again, you would make this list 1, you put your frequencies into list 2, you still do one variable statistics, but now you have to make sure that when you go to calculate those, you have list 1 identified as your X values, and list 2 is your frequency list. So make sure those are both showing on your calculator when you calculate. Give it a try. Make sure that you're doing that right to get this answer. All right. How do you do that? Just a quick reminder on this. How do you do that if it's within classes? So if we have grouped data like this within classes, remember for this, in a calculator, you use a mid-interval as your X values or as list 1. So I would look at this and said, okay, the mid-interval between 200 and 209 is 204.5. So I'm using 204.5, 214.5, so on as list 1. In the last lesson, we just dealt with cumulative frequencies. When you make a cumulative frequency graph, remember they use this number to make the graph. The upper class limit was used to make a graph in cumulative frequencies. That is the only time you use this number. Okay, when you're doing calculator stuff, we always use the mid-interval value for everything. The only time this number is used is for making a cumulative frequency graph. That's it. Everything else, we use the mid-interval to get answers. For this last part, so most of that's done in our calculator, so we really don't do a lot of that by hand. It's just a calculator thing. But this is key. You really want to pay attention to this last section. You need to know what happens to your results when you do something like this to your data. These are popular IB questions. This is their way of forcing some comprehension out of you without the use of a calculator. And they can do that because they will give you numbers, like they'll throw in some variables and do some things that you really can't use your calculator for. And so you need to know what happens to your data when you do things like add or multiply to your data. How does that affect the key statistical values like mean, median, mode, standard deviation, all those type of things? How are those affected when I add or multiply to my data? So pay close attention to this. If I were to take these same data points, so notice here was the mean, here was the standard deviation, here was the variance. What would happen to those outcomes if I added 4 to all of those answers? So all these numbers are being shifted up 4 units. Well, if you add 4, so here's the new results right there. So the question is going to be, well, what would happen to your mean if I added 4? Well, notice what happens to the mean. 4 was added to the mean. So if you add to your data points, you would also add the same amount to your mean to get the new mean. And again, you can always test this with real numbers. So like in an IB question, if they start throwing in variables and make it a way for you to not be able to do this in your calculator, we'll use some real numbers to test it, like I'm doing right now, and apply that same concept to whatever they give you, and that will help. So if I tested this with some real numbers and I would say, oh, well, I just added 4 to the mean, now I can respond to their question by adding 4 to their mean. And so that's just a way of, taking advantage of this with some real numbers. Look what happens to the standard deviation. So for the standard deviation, which was this, notice it did not change. So when we added 4, well, my numbers are still the same distance apart as they always were. Remember, standard deviation recognizes how spread out the data is. Well, if these all shift up 4 units, they have the same spread. They're no farther apart or closer to each other, so they have the same spread, the same distance from each other, and so my standard deviation and variance wouldn't change. But the mean would. The median would, right? The median added 4 to it, right? This was my old median was 7, my new median's 11, so the median added 4. So things like that change, but the standard deviation would not when you add. But look what happens when you multiply. So if I took those same data points, 3, 7, and 14, and I multiply them by 4, so here's the new list, 12, 28, and 56, right? I just times 4 on all the original numbers. We'll notice what would happen. A couple things. One is here's the original median. Look at the new median, times 4. What about the mean? So here was the original mean. Here's the new mean, times 4. So that's something you should definitely be familiar with, how the mean is affected. The mean is simple because it just does whatever this does. So if you're adding, you add to the mean. If you multiply to the mean. And that's consistent all the time. It's the standard deviation and the variance that change a little bit here. So again, notice when you added the standard deviation and variance did not change, but when you multiply, they do. So on these guys, if you took, here was the original standard deviation. When you multiplied all your numbers by 4, well, you also multiply your standard deviation times 4. So that's this little formula that you're seeing right here. It's saying take the original standard deviation and multiply it times 4. With the variance, remember that the variance is the standard deviation squared. So notice here was the original variance, and they're multiplying it times 16. So since because they multiplied by 4, and because the variance is the standard deviation squared, right? Then notice I'm squaring this number. Sorry. So I'm squaring the 4 times the original variance. And so you just need to be familiar with how these are affected when you either add or multiply to your list of data. But like I said, you can always test these with real numbers. So if you're ever given something on a test with variables or some way of them keeping you from doing this in your calculator, test it with real numbers. Even if you didn't have a calculator, test it with easy numbers that's easy for you to work with. If I just pick numbers like a list of 1, 2, 3 and said, well, what would happen if I multiplied those by 4? I can easily figure out by hand the mean, the median, the mode, the range, the standard deviation. I could easily do those things by hand and then just apply what I'm seeing to their list of data to answer their questions.